Welcome to Get Your FRQ On. This question is from the 1999 exam. It's question 5, and it is calculator active. In the question stem, we are given a graph of a function f of x, and a new function g of x is defined as the integral from 1 to x of f of t dt. In part A of the question, we are asked to compute g of 4 and g of negative 2. By definition, the function g of x is the integral from 1 to x of f of t dt. So g of 4 would just be the value of the definite integral from 1 to 4 of f of t dt. The graph consists entirely of line segments, so this area can be calculated by using formulas for trapezoids and triangles and things like that. But when you do find the area, it is 5 over 2. And g of negative 2 would be the value of the definite integral from 1 to negative 2 of f of t dt, which similarly you can calculate by using formulas for various types of polygons. In this case, I believe it turns out to be a triangle, and that area turns out to be negative 6. In part B, we are asked to find the instantaneous rate of change of g with respect to x at x equals 1. Now, since g of x is this integral from 1 to x of f of t dt, by the fundamental theorem of calculus, the derivative of g is simply f of x. So the instantaneous rate of change of g with respect to x at x equals 1 would simply be f of 1, which you can plug right off the graph. If you check the graph, the value of f of 1 is 4. In part C, we are asked to find the absolute minimum value of g on the closed interval from negative 2 to 4 and to provide justification. Now, before I go into the explanation for this, it's important to understand this seems like an application of the extreme value theorem. So in order to use that, I have to be working on a continuous or differentiable function. I'd have to check the endpoints just to make sure, since it's a closed interval. So before I get ahead of myself, I want to make sure that I verify the requirements of the extreme value theorem. Now, because g prime of x is equal to f of x, and f of x is defined for all x on the interval from negative 2 to 4, we may conclude that g of x is in fact differentiable for all x on the open interval from negative 2 to 4. This is simply because every possible value for g prime of x on the interval from negative 2 to 4 is there, because f exists for everything between negative 2 and 4. So g does have a derivative for everything on that interval. So g of x must be differentiable for all x on the open interval from negative 2 to 4, and consequently, this allows us to conclude that g of x is continuous on that open interval from negative 2 to 4. Now, because the closed interval, negative 2 to 4, is a closed interval, the absolute minimum value of g of x could occur at a number of different places. It could occur at either one of the endpoints, negative 2 or 4, or somewhere in that open interval from negative 2 to 4 where g prime of x equals 0. We know we don't have to include the possibility that g prime doesn't exist somewhere, because we've already concluded that it does. So we don't need to account for, well, g prime of x doesn't exist here, so that could be a minimum. It exists everywhere in that interval, so we don't have to worry about it. All right, so when does g prime of x equal 0? Well, it only equals 0 when f of x equals 0, which is at x equals negative 2 and x equals 3. However, if you look at the graph at x equals 3, g prime of x changes sign from positive to negative, which means that g of x would have a maximum value at x equals 3. We are not looking for a maximum here, we are looking for a minimum, so 3 is not our candidate. All right, this leaves only the endpoints as possible locations for absolute minimum values of g on the closed interval from negative 2 to 4, so all we need to do is now check the endpoints. As previously determined in part A of this question, g of negative 2 is negative 6 and g of 4 is 2.5. Therefore, we can conclude that the absolute value or absolute minimum value of g of x on the interval from negative 2 to 4 is in fact negative 6. In part D of this question, we are asked to determine how many of x equals 1 and x equals 2 are inflection points of the graph of g, and to also provide justification for that. The graph of g of x is going to have an inflection point whenever g prime of x changes between increasing and decreasing. And that can go in either direction. It can either go from increasing to decreasing or decreasing to increasing. Either one would indicate an inflection point. Notice that g prime of x is increasing for all x on the open interval from negative 2 to 1, and decreasing for all x on the open interval from negative 1 to 2. So, this tells us that x equals 1 is an inflection point. All right, now let's consider what happens at x equals 2. Notice that g prime of x is decreasing for all x on the open interval from 1 to 2, but also decreasing again for all x on the open interval from 2 to 4. Now, because g of x is, or g prime of x is decreasing on both sides of x equals 2, we would conclude that x equals 2 is not an inflection point. So of the two offerings provided, x equals 1 and x equals 2, only x equals 1 would be an inflection point. All right, and then if you like my videos and you like learning more about AP Calculus free response questions, don't forget to like and subscribe. That way you can be notified whenever I update and upload new solutions and provide more calculator tutorials for graphing calculator questions. Helps out my channel, gets me more views, it lets more people see my content. If you like it, there's a good chance other people will like it too.